Have you ever wondered just how many moons Uranus, the seventh planet from our sun, has? Well, it's a fascinating tale that begins in the year 1787 with the astronomer William Herschel. Herschel, the man who discovered Uranus itself, was also the first to spot two of its moons, Titania and Oberon. Over the next 2 centuries, astronomers continued to scan the skies, their efforts revealing more and more of these celestial companions. By the mid-20th century, the count had risen to 5. But it wasn't until the Voyager 2 spacecraft's historic flyby in the 1980s that the tally soared. Today, we know of 27 moons orbiting Uranus, each one a world in its own right, from tiny rocks to massive bodies like Titania and Oberon. And who knows? As our technology advances and our exploration of the cosmos continues, we may yet discover more. From the late 18th century to the present day, our understanding of Uranus's moons has expanded from just 2 to an impressive 27. But what are these moons made of? And how did they come into existence? Well, Uranus's moons boast a diverse composition, being primarily made up of water ice, rock, and organic materials. The icy part of these moons is so prevalent that if you were to step on one, you'd likely be standing on a frozen ocean. Now, let's rewind the cosmic clock a bit. It is believed that these moons were born from the same disk of material that surrounded Uranus during its early formation. Imagine a swirling, chaotic disk of cosmic debris gradually coalescing into the moons we see today. And what about their orbits? They're as varied as the moons themselves, with some taking notably inclined paths around Uranus. This is largely due to Uranus's unique tilt, which is so extreme that it practically rolls on its side. This tilt contributes to the distinctive orbits of its moons. Thus, the moons of Uranus are a diverse group with varied compositions and orbits, all influenced by the unique characteristics of Uranus itself. And how do these moons interact with each other and with Uranus, you might ask? Well, the interactions are dynamic, complex, and fascinating to say the least. Uranus's moons and its rings are constantly in a celestial dance, each influencing the other's path. This interaction is marked by phenomena such as orbital resonance and gravitational perturbations. Orbital resonance, a gravitational relationship where one moon's orbital period is a simple fraction of another's, plays a significant role. It's a celestial rhythm that keeps the moons in their respective lanes. Gravitational perturbations, on the other hand, can cause moons to deviate from their paths, adding a touch of unpredictability to this cosmic ballet. The Voyager 2 spacecraft, which flew by Uranus in the late 20th century, remains the only spacecraft to have explored this distant planet and its moons. Its valuable data continues to help us understand these intricate interactions. Despite only one spacecraft visiting so far, we've learned a lot about the dynamic interactions within Uranus's lunar system. Why should we care about these distant moons? Well, Uranus's moons aren't just distant orbs of rock and ice. They're a living testament to the history and evolution of the outer solar system. Each moon, with its unique composition and orbit, holds clues about the early stages of our solar system's formation. In a way, they're like cosmic time capsules, waiting to be unlocked. The sheer diversity of these moons is also staggering. From water ice to organic materials, each moon presents a different facet of the processes that shaped Uranus and its surroundings. Their peculiarities, far from being mere quirks, offer valuable insights into the dynamic interplay of celestial bodies and the forces that mold them. So, the next time you gaze up at the night sky, remember that each speck of light tells a story. And in the grand scheme of space exploration, the moons of Uranus offer a unique window into the history and evolution of our solar system.